Okay, ladies and gentlemen, I guess I have two of these to do, so are these that much different? Let's look. Yep, radically different. Okay. So let's get to work. Okay, Stoic test review. This is college prep, CP. So, 4 moles of oxygen. Oh, wait a minute. How many moles of oxygen are produced when 5 moles of potassium chlorate? So I have to identify that. Potassium chlorate. And how many moles of oxygen? So we're going to this. So say moles to moles. Moles to moles, you have to know how to draw these boxes. So moles to moles, one box. And I've been given 5 moles of KClO3. Moles KClO3. And we're going to moles of oxygen. And we have 3 moles of oxygen for every 2 moles of this. 5 times 3 is 15, divided by 2 is 7.5. No calculator needed. Moles to moles, really easy. The only thing I need you to know is you got to know that moles to moles is one box. And you got to know the rules. Moles KClO3, moles KClO3, units of my answer, back in the top right. It's the same every time. And by the end of this video, I'm sure you'll get tired of me saying it, but okay. How many grams of iron are needed to react completely with 10 moles of oxygen? Okay, so it sounds like a moles to grams, or also known as a 2 box. How many grams of iron are needed to react completely with 10 moles of oxygen? All right, diagonal rules. They have to be the same down and to the right. Moles O2. Oh, looks like as far as I can go. Now I'm going to go backwards. Units of my answer go in here. And if I ever see grams, the other side of it is always 1 mole of that substance. I call that the grams rule. 2 rules, 2. 1, units down and to the right have to be the same. So by that same rule, what has to be here? Moles Fe. So this is the heart of the equation, or the mole ratio. It's going to be part of every equation, including this one, the mole ratio. Mole ratio, everything you've been doing. Okay, so how many moles of iron? It's this coefficient here. It's 2. That means I have 2 moles of iron for every 1 mole of O2. I know they don't like to write ones, but there's a hidden 1 there. And grams of iron and 1 mole of iron. So by the periodic table, that is 55.8. We'll just call it 55.8. And now I've got some calculation to do. 10 times 2 is 20. And times 55.8 is 1,116 grams of iron. So for every 10 moles of O2, I need 1,116 grams of iron. Okay, next. How many grams of zinc oxide can be produced from 500 grams of zinc? Oh, so a grams to grams, 3 boxer. Remember, that's a box, that's a box, that's a box. This is just a springboard for what I'm given, 500 grams of zinc. And by the diagonal rule, and by the grams rule, 1 mole zinc. Diagonal rule, grams zinc, 1 mole zinc. And by the diagonal rule again, moles zinc. And that's as far as I can go forward. Let's go backwards. We're looking for grams of zinc oxide. That is zinc oxide. So ZnO. So the units fall back into here. And by the grams rule, 1 mole of zinc oxide. And by the diagonal rule, moles of zinc oxide. Now, I have 2 moles of zinc for every 2 moles of zinc oxide. So 2 moles of zinc, 2 moles of zinc oxide, and grams of zinc in 1 mole, 65.38, or we'll just call it 65.4 grams, and zinc oxide, so 65.4 plus 16, 81.4. And then I've got some math to do on my calculator. Now, 2 over 2 is just 1. I'd prefer that you do all the calculations. So I have 500 times 1 times 2 times 81.4, enter. So that's what I've done so far. And then I'm going to divide by everything on the bottom. Divided by 65.4, enter. Divided by 2, enter. Divided by 1, enter. Looks like I've got 622.32 grams of zinc oxide, which makes sense. They're a 1-to-1 mole, ratio, 500 grams of zinc, and then I'm just adding all the oxygen in. So that's all oxygen, that 122 grams. Okay. Define limiting reactant. Limiting reactant is the reactant that runs out first. It is also the reactant that produces the least product. What is excess reactant? That is the reactant that does not run out when the reaction has ended. Has ended. Ended. Okay. All right. So the formula for sodium oxide is Na2O. You have 12 sodium atoms and 15 atoms, 15 oxygen atoms available. How many compounds can you make? Well, sodium takes 2 atoms per molecule. So I can make 6 with that. Oxygen uses 1 atom per molecule. So I can make 15 with that. So I can make 6 molecules. How many compounds? Well, I can make 1 compound. How many molecules did you mean? Yeah, I can make 6 molecules. What is the limiting reactant? It is sodium because it can make the least. What is the excess reactant? It is oxygen. Wow, that's pretty brainless. You also could have done this as moles. And you could have done a very simple, moles to moles of your compound, but whatever, that's easier. How many of the excess reactant do you have left over? Okay, well, so I need to make 6, so I need to use 6 oxygens, so I have 9 oxygens left over. 9 oxygens. Oh, it's painful writing that without a 2 here. But I don't have 9 O2s. Okay. After an experiment, you have 25 grams of product. You think that's actual or theoretical? Well, after an experiment, I actually have a product, don't I? So I have an actual, and I have a theoretical. Anytime it says calculate, times 100. So 25 divided by 33 times 100, enter. So equals 75.75% yield. That is how you calculate percent yield. Remember, it is actual over theoretical times 100. And that's what I did. Actual over theoretical times 100. Just remember that the actual is 99.9% of the time is smaller than your theoretical. So for this class, for this test in particular, put the smaller number on top. If you get something over 100%, then try it the other way around. Is that? No, surely that's not it. That's it? Those 6 questions? Okay, forget it. I'm just going to keep going, and I'm going to do the honor Stoic review, and we can just do this. All right, I got to balance this thing up. Okay, that's balanced. That looked really hard. In the chemical reaction above, come on. Stupid, dumb. God, all right, you can turn on anytime you like. Okay, in the chemical reaction above, what is the mole ratio between oxygen and magnesium oxide? So this is oxygen, this is magnesium oxide, so it is therefore 1 to 2. That's pretty brainless. Okay. Okay, so we got to balance this thing up too. So let's see, I'm going to do a 2 there. That's going to give me 6, and that's going to give me, holy mackerel, 10, 11. Okay, wait a minute. 2, that gives me 8. Not enough oxygens. Oh, why did they have to make this tricky? How about if I make it 5? No. Let's see. PO4, let's see, we got 4, 2, 3 would be 8, be 12. Then I could put a 2 out here. 3 times 3 would be 9. No, never going to get that to happen. Oh my goodness. I guess I'm going to have to do atom counts. All right. P, let's just do them over here. P and O and H. 4, 10, nope, 11, 2. On this side, I have 3 and 1 and 4 oxygens. Okay. So if I do that, 6 hydrogens, 3, that's 10, that's 13. Nope, it's got to be something even. Can't do that. Okay. So, oh, my brain. Being 6 stinks. 10, 11, 12. So the smallest I'm ever going to get this to be is 12, so I'm going to put a 3 out here. That gives me 9 hydrogens. And it can't be odd, so it can't be that. It's going to have to be the next number up. So let's make it 6. So 6 and 3 is 18. And 6 is 24. And 6 is 6. All right, let's see if I can't do that. It's got to be 8. Son of a... Wait a minute. Would 4 work? 4 times 4 is 16. Oh, wait a minute. Wait a minute. 4. That gives me 12 hydrogens. That gives me 16 oxygens. And that gives me 4 phosphoruses. So they're all set. And then I got 10 and I need 16, so I need another 6, so 6, and that's 6 times that is 12. Ah, we found it. We found it. 10 plus 6 is 16. Aha. So it's 164. Oh my god. Sorry that took so long. And I didn't edit it out in post. Okay, in the above reaction, what is the mole ratio between tetraphosphorus decaoxide, that's that, and water? So it is 1 to 6. Why would they ask me 2 mole ratios? That seems kind of pointless on an honors chemistry. Okay, how many moles of tetraphosphorus decoxide would be required to do? Okay, so moles to moles. So, and I need my blank sheet again. Let's just do it up here. Moles to moles. P4O10. Wait a minute, did they give me moles? No. 20 moles of phosphoric acid. H3PO4. 20 moles H3PO4. So this has to be moles of H3PO4, and we're going to moles of P4O10. And the mole ratio is one of these for every 4 of these. 20 divided by 4 is equal to 5. 5 moles of H3. Oh, sorry. I mean, god dang it. Tetraphosphorus dicoxide. Sorry about that, guys. I'm sick. The meds are kicking in. I'm going to do my best work, but I'm going to make mistakes. How many grams of water would be required to fully react with 8 moles of another? Okay, grams. Moles to grams. So 2 boxes. And we're starting out with 8 moles of P4O10. Moles P4O10 by the diagonal rule, and then I'm stopped, and I'm going to grams of water. So this has to be grams of water, and by the grams rule, I have to write 1 mole of water above or below that. And anytime I see grams, I have to write 1 mole of that substance, and then by the diagonal rule, moles of H2O. And for every 6 moles of H2O, there are 1 mole of this. And there are 18 grams of H2O in every 1 mole. Okay, so what we have is 8 times 6 times 18 divided by 1 divided by 1. Wow, that's a lot of grams. 81.82 grams of water. Now that's an answer to really make you puzzle. But it is 8 moles, and it is a 6-to-1 ratio, so 8 times 6 of that. So basically 48 moles of water. Why am I getting a different answer? 8 times 6, enter, times 18, enter. Oh, because I entered it wrong. That's why I got a big number. See? You see what happens? So 8 times 6 times 18, and it is 864 grams of water. You can't listen to me about anything today. I'm just not. Oh, I guess I could put the answer there. And I guess I could put this answer here. I guess I could put the ratio there. Okay. Can we carry on? Y'all keep interrupting me. Okay, so we have 8 grams to moles. Also 2 boxes. 100 grams of phosphoric acid, 100 grams of H3PO4. This has to be, oops, I don't want to get out of the screen here. Grams by the diagonal rule has to be grams of H3PO4. By the grams rule has to be 1 mole of H3PO4. By the diagonal rule has to be moles of H3PO4. As far as I can go forwards, so then I need moles of P4D O10. Moles P4O10. And the mole ratio is 1 of those for every 4 of those. And in H3PO4, we have 4 oxygens, which is 64, plus a phosphorus, which is 31, plus 3 hydrogens. So I get 98 grams. If you get something different, you're probably right. Well, maybe not. So 100 times 1 times 1 divided by 98, enter, divided by 4, enter, 0.255 moles of P4O10. 0.255 moles of P4O10. All right, and then we got a grams to grams. Okay, let's just flip this. Well, no, we can't do that. Let's flip this one over. Go to grams to grams. How many grams of phosphoric acid? So I know I'm going to have grams of H3PO4 on one end. And 500 grams of, you know it, tetraphosphorus. 500 grams of tetraphosphorus decoxide. Grams of P4O10. 1 mole P4O10. Mole P4O10. Okay, now I gotta go backwards. Grams H3PO4. By the grams rule, 1 mole H3PO4. And by the diagonal rule, moles of H3PO4. I have the heart of the problem, the mole ratio, and moles of H3PO4 I have 4 of, and this I have 1 of, and H3PO4. Didn't I just work that out? Please tell me I just worked that out. Oh, wait a minute. Yes, 98 grams. 98 grams. And then P4O10. So 160 plus 31 times 4. So 284. Okay, math. 500 times 1 times 4 times 98 divided by 284, enter, divided by 1 equals 690.14 grams of H3PO4. I hope that's right. 690.14 grams H3PO4. All right, in an experiment, 300 grams of propane were reacted with 800 grams of oxygen, forming carbon dioxide and water. Combustion. Don't you love it? Let's just see if we can make this easy. 3, so that's 6, okay, 2, no, 4. 4. So that's 8 hydrogens, got it. 3 carbons, got it. That's 6 oxygens plus 4 oxygens is 10 oxygens. 5, I think we are there. If you don't know how to balance by now, I don't know what to tell you. You need to come in and we need to sit down and do a bunch of soul searching. 8, 4, 6. Nope, that's right. Okay. In the above reaction, which substance is the limiting reactant and how many grams of carbon dioxide can be theoretically produced? Okay. So that's 2 grams to grams reactions. And they're asking me specifically about grams of carbon dioxide. And they've given me 300 grams of propane, which those of you who don't know propane, it's that right there. And they've given me 800 grams of oxygen. O2. Okay, so now it's just working, it's working these two problems out and figuring out which one gives me the least, right? Which one gives me the least product? Okay, so grams C3H8, 1 mole by the grams rule, C3H8, moles, C3H8, grams, CO2, grams rule, 1 mole, CO2, diagonal rule, moles, CO2, 3 moles of CO2 for every 1 mole of this, and then CO2, let's see, that's 3244 grams, and C3H8 is 44. How is that possible? They have the exact same molecular weight. True it is, though. Okay, so now it's math for that one, but let's go ahead and do this one too. Grams of O2, and let's just go ahead and do that as 32. And by the grams rule, 1 mole O2, and by the diagonal rule, moles of O2, and then by these units go in here, rule. Ah! Come on! I'm trying to work here, people. Why? Why, God? Where was I? Yeah. Oh, by the grams rule, 1 mole CO2, and then up here, moles CO2, 44 grams of CO2, moles of O2 are 5, moles of CO2 are 3. All right, I got 2 math problems to do here. 300 times 1 times 3 times 44, enter, divided by 44, enter, divided by 1, enter, divided by 1, enter. So it looks like 900 grams, which makes sense. These 44s cancel each other out. These 1s cancel each other out. So it's just 300 times 3. Now the bottom, 800 times 3 times 44, enter, divided by 32, divided by 5, divided by 1. Looks like 660 grams. So it looks like this is my limiting reactant. And this is how much I can actually make. 660, not 666. What are you trying to tell me there, buddy? Limiting reactant is O2. Theoretical yield is 660 grams of CO2. Okay, what else we got here? Calculate the percent yield if the actual is 575. So actual over theoretical times 100. 575 divided by 660 times 100. I get 87.12%. Is that it? Yep, that's it. I know this hasn't been my most spectacular work ever. I still hope that you get something out of it. And I will see you in the morning. Come ready to take a test. See you guys.